Welcome young scientists to an exciting world of SmartClass. And today we embark on a thrilling exploration of one of nature's fundamental forces, friction. Friction is a phenomenon you encounter every day, whether you're riding a bicycle, walking on a street, or even just picking up a pencil. It's a force that affects our lives in numerous ways, both visible and invisible. In this extensive journey, we'll delve deep into the concept of friction, understanding its origins, its importance, and how we can harness or minimize it to our advantage. So fasten your seatbelts and get ready to uncover the secrets of friction. What is friction? Let's begin with the basics. What is friction, you might wonder? Well, it's the force that opposes the relative motion between two surfaces in contact. Think about it this way. Have you ever tried pushing a heavy object across the floor? The resistance you feel when you do that is due to friction. Now imagine a car coming to a halt at a traffic signal, or your bicycle slowing down when you squeeze the brakes. These are all examples of friction at work. But friction doesn't just apply to vehicles. It's everywhere around us, influencing our daily lives in countless ways. Force of friction. To understand friction better, let's conduct a simple experiment. Place a book on a table and gently push it. You'll notice that it doesn't keep moving forever. It eventually comes to a stop. Have you ever wondered why? This happens because of force of friction. When you push the book, there's a force acting in the opposite direction. In other words, the friction between the book and the table is resisting the motion of the book. It's like a natural brake that slows things down. Factors affecting friction. Now let's dig deeper into the intriguing world of friction. Is friction the same for all surfaces? Does it depend on how smooth those surfaces are? Let's find out through a fascinating experiment. Take a moment to tie a string around a brick. Then use a spring balance to pull the brick. Note down the reading on the spring balance when the brick just starts to move. This reading gives us a measure of the force of friction between the surface of the brick and the floor. Now try repeating this experiment by wrapping a piece of jute bag around the brick. What do you observe? Does the friction change? It turns out that the roughness of the surfaces does indeed affect the friction. Static and sliding friction. As you've seen in our experiment, friction comes in different flavors. When you're trying to move an object from rest, you're dealing with static friction. It is the force required to overcome the initial resistance to motion. It's like the invisible hand that keeps objects in place until you apply a stronger force to get them moving. Now consider the scenario when the object is already in motion. The force required to keep it moving at a constant speed is known as sliding friction. Interestingly, sliding friction is slightly less than static friction, making it somewhat easier to keep things moving than to start them from rest. Friction, a necessary evil. It's time to reflect on the importance of friction in our lives. Have you ever wondered why you can grip a glass tumbler more easily than a greasy one? Or why walking on a wet, muddy track is challenging? Friction plays a vital role in all these scenarios. It's what makes it possible to hold objects, walk, and even write with a pen or a pencil. Think about it. When your teacher writes with chalk on the blackboard, Friction helps the chalk particles to stick to the board. But, and this is where the evil part comes in, friction can also wear things out. Screws, ball bearings, and the soles of shoes are just a few examples of items that can deteriorate due to friction. Even steps on the footover bridges at railway stations show signs of wear and tear because of people walking on them. Increasing and reducing friction. In some situations, we want to increase friction for better grip and control. For example, sports shoes have spiked soles to provide better traction on the ground. Brake pads in bicycles and automobiles intentionally increase friction when you apply the brakes, helping you to come to a stop safely. Conversely, there are times when we aim to reduce friction. Ever wondered why we sprinkle fine powder on a carom board? It's to make the surface smoother, reducing friction and allowing the carom pieces to slide easily. Lubricants like oil, grease, or graphite create a thin layer between moving parts of machines, reducing direct contact and minimizing friction. Wheels reduce friction. One of the greatest inventions that help reduce friction is the wheel. Wheels are everywhere, on cars, bicycles, and even luggage. The reason they work so well is that they reduce the friction between the object and the surface it moves on. But that's not all. To further reduce friction, we use ball bearings in various machines. Ball bearings are small spheres placed between moving parts, allowing them to roll instead of slide. This rolling action reduces friction, making machines more efficient and long-lasting. Fluid friction. Now let's explore another aspect of friction: fluid friction. In the world of science, gases and liquids are collectively referred to as fluids. When objects move through these fluids, they experience a force of friction known as drag. The amount of drag depends on several factors, including the speed of the object, the shape of the object, and the nature of the fluid. Think about birds soaring through the air or fish gracefully gliding through water. Their bodies have evolved to minimize drag, allowing them to move efficiently. Let's pause and recap our incredible journey through the world of friction. We've unearthed the secrets of this fascinating force, understanding how it's both a friend and a foe in our lives. Now to recap, friction opposes the relative motion between two surfaces. It depends on surface smoothness and pressure. There's static friction, that is starting, and sliding friction, that's ongoing. Friction is essential for walking, writing, and stopping vehicles. We can increase or reduce friction as needed. Wheels and ball bearings help reduce friction. Fluids like air and water also create friction. As we conclude our journey, remember that science is an endless adventure waiting for you to explore further. Hope you liked the video. Please do like, share, and subscribe to SmartClass and click on the bell icon. Stay curious, keep asking questions, and never stop learning. The world of science is full of wonders, and friction is just one of its many mysteries.